Today we are going to discuss about deduction from Moivres theorem. First is the expansion of cosine theta and sine theta in powers of cos theta and sine theta. Deduction from Moivres theorem. First is expansion of cosine theta and sine theta in powers of cos theta and sine theta. We know the De Moivres theorem for cos theta plus I sin theta to the power n is equal to cos n theta plus I sin n theta, where n is positive, negative, integral or fractional. We have this value. Now expand this by using binomial expansion. A plus b to the power n equal to nc naught a n nc1 a n minus 1 b plus nc2 a n minus 2 b square plus dot 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 plus dot 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 nc n minus 1. This is a b n minus 1 nc n b n. This implies cos n theta plus I sin n theta. Here I will expand this by using binomial expansion. This one I will get this value nc naught cos theta plus nc1 cos theta cos n theta. This is cos n theta a to the power n. So cos n theta. This is cos n minus 1 theta. This is I sin theta. This is nc2 cos n minus 2 theta I sin the square plus nc3 cos n minus 3 theta I sin theta cube plus nc4 cos n minus 4 theta I sin theta 4 plus nc5 cos theta n minus 5 theta I sin theta to the power 5 plus dot 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 plus nc n minus 1 cos theta I sin theta n minus 1 plus ncn I sin theta to the power n. Simplify this one. This is equal to nc naught cos n theta. Here this I will write it deeply of the term. This is nc1 cos of n minus 1 theta sin theta. Then this is I square is minus 1, so this is minus nc2 n minus 2 theta sine square theta. Okay, this is I cube. I cube is my I cube is equal to I square I, that is minus I. Okay, so this is minus I and C3 cos of n minus 3 theta sine cube theta. Okay, this is I to the power 4. So I to the power 4 is my 1 and C4 cos n minus 4 theta sine 4 theta. Okay, then and C5 I5 is written as I4 into I, that is 1, this I. So plus I and C5 cos of n minus 5. This is theta sine 5 theta. Then this term NCM cos theta I sine theta and minus 1 sine theta. This is put this equation 1. Okay, this is equation 1. Now write real with real, imaginary with imaginary. This implies cos n theta plus I sine n theta is equal to this one. Okay, so sorry, cos n theta plus I sine n theta is equal to this one. This implies cos n theta plus I sine n theta is equal to, I'm writing real with real and C not cos n theta. The next real part is this one, minus NC2 cos n minus 2 theta sine square theta. Then next real will be this one. So write this NC4 cos n minus 4 theta sine 4 theta. Okay. Then write the imaginary part. Imaginary part will be this NC1 cos n minus 1 theta sine theta. Then this one minus NC3 cos of n minus 3 theta sine 2 theta. Then fifth one this plus NC5 cos of n minus 5 theta sine theta. So next I'm not going to wrap this one. I will use this in the subsequent stage. So I will not wrap this one. Next, write equating real and imaginary part we get here cos n theta will be equal to cos n theta is equal to this part, and cos n theta will be my this one, and here NC not cos n theta minus NC2 cos n minus 2 theta sine square theta and C4 cos n minus 4 theta sine 4 theta this is my equation 2. Okay. And cos and sin and theta, real part, imaginary part with imaginary part. Equal to NC1 cos n minus 1 theta sin theta, NC3 cos n minus 3 theta sin cube theta, NC5 cos n minus 5 theta sin 5 theta. The term in both the series are alternate positive and negative. The term in both the series are alternate positive and negative. These series are true when n is both odd and even. Only difference is in the last term. So write the terms of both the series are alternate positive and negative. Okay, both these series are true for n true when n is odd or even. Only difference is in last term. Okay, only difference is in the last term. Now we are going to find out this series when n is odd and when n is even. Case 1. When n is even. Let n will be equal to 2m, where m is a positive integer. M is positive integer. Okay. The last term here is this one, and say n is 1. So I will find what is the value of this. This is in sin n theta. Here I is my 2m. By law of indices, I can write it as this. I square is my minus 1 and m is from here n by 2 sin n theta, which is real. Now the term before the last term, this is this one, n c n minus 1 cos theta I sin theta n minus 1. And n minus 1 is this. This is equal to this by this n minus 1 and minus n plus 1. This cancel out. This is factorial 1 and this is n. Okay. This is n minus 2 and minus 1. This cancel out. This is n. Factorial n is 1. So this is equal to my n. Okay. Cos theta. Here it is I to the power n minus 1. Then sin theta. This is equal to n cos theta I, and value of n is 2m minus 1 sin theta. Okay. So in next step, I can put here n cos theta. I can write sine n minus 1 theta. N minus 1 theta. Okay. So sine n minus 1 theta. This is equal to n cos theta. I'm taking here square and this is n minus 1. This can be taken as 2 into n minus 1. Then I will take 2 inside. This is I square n minus 1 sine n minus 1 theta. So this is equal to I into n cos theta. I square is minus 1. M from here is n by 2. N by 2 minus 1 sine n minus 1 theta. This is imaginary. So last term when n is even, last term of cos n theta is this one, and cos n theta series is this one, and sin n theta series is this one. Okay. Now when n is odd, okay, what will be the last term? When n is odd, then this is equal to 2m plus 1. And here it is 2m plus 1. Here it will be changes. It is equal to I2m sine and theta. If we add the power, we will get this thing. This is equal to I square m sine and theta. This is equal to I minus 1. M is n minus 1 by 2. Okay? N minus 1 by 2 sine and theta. So when n is odd, this is the imaginary part. Now we are going to find out the term before the last. When n is odd. When n is odd, this is n cos theta I to the power n minus 1 sine n minus 1 theta. This is n cos theta I n minus 1 will be I twice m sine n minus 1 theta. This can be written as cos theta. This is I square m sine n minus 1 theta. And cos theta minus 1. What is ham? Ham is n minus. Bring 1 to this side. This is n minus 1. Then divide it by 2. You will get the value of m. That is n minus 1 by 2. And sine n minus 1 theta. So when n is odd, the last term of cosine series is this one. And last term of sine and theta is this one. Okay. That is this series. With that, I would like to conclude. Remaining will be in the next lecture. Thank you.